Bill Snodgrass, and in this episode of The World Around Us, we're starting down the path of Stoichiometry, fancy word that means how much of this and how much of this go together to make how much of that. Moles to moles. This is the first step. Like, if once you master these concepts and develop these skills, I don't know, you're probably ready for a job at, Fermilab or NASA or DuPont or someplace that makes chemicals and things. You're probably ready once you master these concepts. All right, let's get serious. Moles to moles stoichiometry. How much of this plus how much of this creates how much of this and that, whatever. It starts with the balanced equation. And that balanced chemical equation is going to give us a proportion, how many parts of this and how many parts of this create how many parts of that. We do this all the time. We do this. We do stoichiometry in the kitchen of all places pretty much every time we make something. How do you make your ham and cheese sandwich? How many slices of bread? How much cheese? I'm going with 2. And some ham, I don't know, let's say, I don't know how your ham is sliced. Let's say you actually have sliced ham. Maybe you do 3 slices of ham, 2 slices of cheese, and 2 pieces of bread. And that makes 1 sandwich. So you have a ratio of 2 to 2 to 3 creates 1. We do this all the time. Hamburgers are super simple. 1 bun, 1 patty, 1 hamburger. 1 bun, 1 patty, 1 hamburger. So stoichiometry is saying, what if I don't have that exact combination? How many can I make? How many whats can I make out of if I'm given this amount? If you have 4 hamburger buns, how many patties do you need? You need 4 patties, 4 buns, 4 patties, 4 burgers. If you have 27 people to feed, you need 27 hamburgers. Now here, the real challenge is hamburgers come like 6 in a pack or 8 in a pack. You got to figure that out. That's the real challenge, because if you're going to feed 27 people, you need 27 buns. If you need 27 buns, you need 27 patties. Super simple. How much do you have? How much is it going to make? That's kind of the question. When we're dealing in the lab, in chemistry lab, we're not dealing with 27 anythings. We're dealing with smaller fractions of that. So in order to illustrate that, I'm going to give you another example. I'm going to give you an example of some kind of large quantity fertilizer. Let's say that you have a big tank, and in order to create 1 tank full of fertilizer, it takes 2 gallons of the concentrated fertilizer and 44 gallons of water. 2 gallons, 44 gallons makes 1 tank. If you're mixing Roundup, you're going to take like 2 ounces and the container holds like, I don't know, my container holds 2 gallons, and I think it's 4 ounces of Roundup. 2 gallons of water creates 1 tank of Roundup. So it's a ratio, it's a proportion. Well, what happens if I'm trying to do 2 gallons, 44, 1 tank? What if I only have 1 gallon of fertilizer? I have half as much fertilizer concentrate as I need. Therefore, I'm going to cut everything in half. 1 gallon is half of the 2 that I needed. And that's going to mean that I only need half as much of the recipe water. So instead of 44 gallons, I'm only going to use 22 because I only had half as much to start with. This makes perfect sense. We do this all the time. If I'm mixing Roundup and I don't want an entire 2.5 gallon, whatever container full, then I just cut my recipe. If I'm baking chocolate chip cookies and I find a recipe that makes 4 dozen cookies, but I only want 1 dozen. I don't want 4 dozen cookies. I only want 1 dozen. Then I'm going to cut the entire recipe by 1/4. So instead of starting with, I have no earthly idea how to make chocolate chip cookies. Let's say you need 4 cups of flour. I don't even know flour's in chocolate chip cookies. But let's say there is. If the recipe that makes 4 dozen starts with 4 cups of flour and you only want 1 dozen, you're going to cut that. Okay, we got the concept. We have some proportion, some recipe proportion, and we're going to figure out what we have and how much we're going to need. For chemistry, that proportion is the balanced equation. So if I have an equation such as potassium plus oxygen yields K2O, and it forms in a certain ratio. And so that ratio for that reaction is 4:1 yields 2. So I take however much of the potassium that I have and divide by how much I thought I was supposed to have, the recipe. How much do I have divided by how much am I supposed to have? And that gives me a number, and then I multiply the entire ratio by that thing. So let's go back to the fertilizer. 2 gallons, 44 gallons. So 2 gallons of fertilizer, 44 gallons of water makes 1 tank. If I only have 1 gallon, 1 divided by 2 is 0.5. 0.5 times 44 is 22. So if I have 1 gallon of fertilizer, it's half as much as I need. I take 1 divided by what I was supposed to have. That gives me a number that I multiply by the supposed to haves for the rest of the ratio. So I'm supposed to have 1 tank when I'm done. I'll only have 1 times 0.5. I'll only have 0.5 of tanks when I'm done. I'm supposed to have 44 gallons, so I have 1 gallon of fertilizer divided by 2 is 0.5. 0.5 times 44 is 22. Same equation, but let's just assume I only have 0.5 gallons of the fertilizer concentrate. So I take what I have, 0.5, divided it by 2. 0.5 divided by 2 is 0.25. Now I take the 0.25 and multiply it by the 44 and the 1. So 0.25 times 44 is 11. I only need 11 gallons of water, and I'm only going to produce 0.25 tanks of fertilizer. Same thing in chemistry. If I'm supposed to have 4 of this potassium, and I only have 0.5, I'm going to take the 0.5, I'm divided by the 4, and that's going to give me a small number. I'm going to take that small number, and I'm going to multiply it by the 1, and that smaller number is how much oxygen I am supposed to mix with 0.5 moles. I said it. I said the word. I brought it in. That's that word, that moles, that thing that we get off the periodic table. All right? All right, so let's do that math. Let's get the calculator out and do that math. We'll do that math. So what I said was you're supposed to have our ratio for potassium is 4:1 to 2. And I only have 0.5 of the thing I'm supposed to have 4 of. I have 0.5 moles. So I take 0.5 and I divide that by what I'm supposed to have, which is 4, and that gives me the fraction 0.125. 0.125 times the whole ratio, so 0.125 times the 4, 0.125 times the 1 is 0.125. So if I'm starting with a half of a mole of the potassium, then I only need an eighth of a mole, 0.125 moles of the oxygen. And I'm only going to produce 0.25 moles of the product. There's the math on the screen. You can see how that came out. So the process is really simple. If you can just do the same thing every time, and the process is this: what do you got divided by what are you supposed to have, and that gives you a multiplier. And then take the entire ratio, whatever it is, 6 to 2 to 3, or 5 to 9 to 28, or whatever, take that ratio, multiply it by that multiplier that you came up with. What do you got divided by what you're supposed to have times everything? And that will give you a way of going from moles to moles in any situation. Also, if you're trying to bake cookies and you actually have a cookie recipe, but you don't have, as much brown sugar as you're supposed to have, so you can just divide the whole recipe by what do you got, by what you're supposed to have, then multiply everything by that. It works in the kitchen just like it works in the lab. All right, lots of things spouted out here. Listen, go back and look at each example that I gave. Make sure you understand each example, and if you do, take some time, put some time into this. This is not one of those things where you're like, oh, it's a pen. Yeah, it's a pen. This is a complicated concept. It's mathematical, which throws some people off. So I get it. It's going to be a little bit challenging, but it's not that hard. It's really take what you got, divide by what you're supposed to have, multiply everything by that, bam, you are done. And so is this video. Thank you for watching. Please click the like button, subscribe to the channel, sign up for notifications, leave me a comment, question, or suggestion. From this video, we're going to go grams to moles to moles, and then moles back to grams. Oh, things are about to get interesting. Things are about to get interesting. Moles to grams, you multiply, grams to moles divide. Memorize that now. It'll help you later on. That's it. See you in the next episode.